Okay, a couple of problems computing derivatives using this new rule, the product rule. Okay, now you have to kind of bear with me in these examples as well as the ones you do in the book or in the homework, because most of the rules, most of the derivatives we compute using the product rule in this section, we could actually work around using the product rule. Okay, so for instance, let's look at this one. I want to find the derivative of the function that is x squared times x cubed. Okay, now if you're savvy, you might have noticed that this is actually just x to the fifth. So we could just write that as x to the fifth, and then we don't need a product rule. Of course, the goal in this section is to get practice with the product rule, so we don't want to do that. But you will see that in some circumstances in the future, we need this new rule. So I want to get some practice here. So the product rule helps us compute a derivative when we're trying to find the derivative of two less complicated functions multiplied together. Okay, so a perfect application of it here. I've got x squared times x cubed, and I want to find the derivative of that. Okay. Now, what the product rule says, and it always confuses me because it's written a little bit differently in every book, but in our book they say the product rule is the following: that if we have two functions multiplied together, f and g, we'll call this one f and this one g, the derivative of f times g is the function f, times the derivative of g plus g times the derivative of f. Okay. So you don't actually even have to write the rule down if it's pretty clear to you what the two functions are. Okay. So in this function, in this problem, the two functions are x squared, that's the one I'll call f, and x cubed, which is what I'll call g. So to compute the derivative here, well, the product rule says take the first function and write it down, okay, and multiply it by the derivative of the second function. Well, the derivative of x cubed is 3x squared. Okay. And then to that we add the second function, x cubed, times the derivative of the first, which derivative of x squared is 2x. Okay. So what we get here is, it's going to be 3x to the fourth plus 2x to the fourth, which is 5x to the fourth. Okay. So that's the derivative of this product of two functions using the product rule. Okay. Now again, if you had noticed that you can actually just multiply these together to get x to the fifth, you wouldn't have needed the product rule at all, and you would have gotten, of course, the same derivative. But the goal here is to try using the product rule, so that's what we get in any case. Okay, so another one over here, very similar. Two functions multiplied together, and yet again, if we wanted to, we could just go ahead and FOIL these two things together and get rid of that multiplication. We only need the product rule when we have two functions multiplied together. Now, if we were to FOIL these two expressions together, we would get several powers of x, basically just a big polynomial, which we don't need the product rule for, because we can just take the derivative of each power of x separately and add or subtract the results. Okay, but we want to practice using the product rule, so again, I can go right to it. If I have the product rule kind of in front of me, how do I apply it? Well, I clearly have a product of two functions here. Okay, product rule says take the first function, x squared plus 2, okay, times the derivative of the second function. Okay, now this is the point where we're going to start cutting down the amount of work we show for derivatives. It helps a lot if you can do a little bit of this in your head and kind of avoid writing too much. And I don't want to write too much to make the problem too long. Well, what's the derivative of x plus 3? Well, to get the derivative of x, we use the power rule, which gives us 1 times x to the power of 0, which is just 1. And the derivative of 3 is 0. 3 is a constant. So the derivative of this whole function, if you can do that in your head, you can just write down the answer, is 1. Okay. Now, to that we add the second function, x plus 3, times the derivative of the first. Okay, and the first function was x squared plus 2. Well, what's the derivative of that? Now let's take it turn by turn. The derivative of x squared is 2x, and the derivative of 2 is 0. So that's just 2x. So just like in every time we use the product rule, I've got the first function times the derivative of the second, plus the second function times the derivative of the first. Okay. And basically that's the answer. Probably they want us to simplify this, so I'll go ahead and distribute everything together and combine like terms. This is just x squared plus 2 if I distribute the 1 inside. And then if I distribute the 2x in here, I'll get 2x squared plus 6x. So at the very end, I'm going to have 3x squared plus 6x plus 2. And that's our final answer.